This is sample problem 4.04 from the Walker book. And this is an example of a projectile motion problem for a projectile that is launched horizontally. And the situation here is that this rescue capsule, I guess, is going to be launched. Really, it's dropped, but it's dropped from a plane that is moving horizontally. And so when that happens, it's this capsule, I don't know, maybe it's like some relief supplies, like a first aid kit or something. And so because the plane is moving sideways, then so is the capsule. It's got the same velocity as the plane because it came from inside the plane. And so it counts as a projectile that is launched horizontally. It has no vertical velocity to begin with because it wasn't launched upward or downward. It's just released from the plane, which was moving sideways to begin with. And so it's going to follow this trajectory through the air. And the idea is that the pilot's going to aim it so that it, gets to the person in the lifeboat. And the question here is, what should be the angle that the pilot sees the lifeboat at when the release is made? It's kind of a way of asking, like, how far away should the plane be horizontally from the boat? Okay, so in other words, what we really need to know in order to find this angle is how far horizontally from the point of release should the plane be when it lets go of the capsule. And so that would be like delta x basically, because then once we know that, we will know this angle that they're asking for. We already know delta y because we know how high the plane is above the water. And the other piece of information that we know is the speed in the x direction. So it's helpful to just split the information into x and y. Let's do that. Let's try writing smaller. Okay, so if I'm writing the x information, what do I know? I have, let's say that I'm beginning at where this plane is going to be 0. I am looking for the distance basically. So let's say this is x0 here, and this is x. I could also do it the other way around, but I'm really looking for the change in x. I know the x velocity, which is not changing. I could call it vx0, but it's going to stay the same because if we ignore air resistance, then the capsule itself is not going to change velocity. It's going to keep the velocity it has because gravity doesn't affect the x portion of the velocity. And that's another way of saying it's not accelerating in the x direction. I don't know the time. The y direction stuff, I know that the capsule begins 500 meters up in the air and it falls to the surface of the water, and then it does not have a velocity in the y direction. It's not moving up or down to begin with. Now it's going to gain velocity, or it's going to gain speed, I should say, in the y direction, but that's later on. Hold on, let me make more space. And then I also know that I'm in a free fall situation here. Like this is acceleration due to gravity in the y direction. So what determines what these two directions have in time or have in common is time. And that time in this case is set by that height of 500 meters. That gravity is going to pull this capsule down in a certain amount of time based on that height. And so if I find the time for that height, that lets me solve for the distance it will go in x based on that velocity. So that's the first step, is to find the time it will take gravity to pull that capsule down. So let's first find that. Given the information that I have, I'm gonna need, let's see here. I don't have a final velocity, so that limits me to the second equation on your pink packet. So let's do that one. I've got y is y0. And then I'm gonna go plugging and chugging here with the information I have. This whole term, 0 times time, is just going to be 0. And then I've got my usual 1/2 AT squared stuff over here. I'm going to have to skip this question and save that for later. Okay, so then when I move the 500, or I should say add 4.9 to both, to the other side, that gets rid of the negative. And then solve for t. Okay, so I get time is 10.1 seconds if I'm keeping 3 sig figs. Okay, so now I can use that, and that same amount of time is the time that it's moving horizontally. So that lets me solve for how far it's going to go in the x direction, because all of that time it's moving to the right on my picture. And for the x direction, I know it's not accelerating. So if I'm using that same equation for x, I mean, I can write it all out just to be thorough, but this whole acceleration term is going to go away. So I have, sorry, I'm solving for x. I was saying it started at 0. I have 55 meters per second here times 10.1 seconds plus this is 0 because I'm saying there's no air resistance, which is kind of bogus, but we're going with it. Times 55. So then I get a huge distance because the plane's going very fast. I guess if I round to 3 sig figs, I get 556 meters. And then finally, I could solve for that angle. So now I have enough information. This is 556. And that pilot would be trying to hit an angle from their line of sight. Let's see here. I'm looking, this is the opposite, and this is adjacent. And so I would use tangent, TOA. Yeah, and so I'd solve for that angle and say that tangent theta would be the 556 over the 500. So then I'd have to do inverse tangent of that ratio on my calculator to find that angle. And when you do that, the book says, I'm cheating here, that I get 48 degrees. Okay. And then the last part, part B, it says, when it actually hits the water, it's going to be hitting at an angle, right? Because now it's got not only the sideways velocity, but it also has a downward velocity. It's got a Vx and a Vy at this moment. Because gravity sped it up. So what they're asking for is the magnitude of the velocity overall. Let's quick solve for that. Okay, so in order to do that, I need to find what is Vy. Vx hasn't changed, okay? But I need to know Vy, which probably the fastest way to get that is to use the first equation on the sheet because it had no velocity in the y direction to begin with, and it's been speeding up in the y direction for 10.1 seconds. Okay, so then I'm going to get .0, I guess, meters per second. And then in order to find the magnitude of Vy, they want to know what is the speed, okay? So then I need to do square root of Vx squared plus Vy squared. So to do that, I've got to go 55. That's the Vx. And then I just solve for Vy. Okay, and when I go there, then I get 113 meters per second.